When we define the continuity property of tastes mathematically, we reference the concept of a converging sequence of points. This graph illustrates one example of such a converging sequence. Our sequence of bundles will begin with bundle B, and it will converge to bundle A. By converge, we mean it will get closer and closer to bundle A without ever reaching bundle A. The first bundle in our sequence is then bundle B, and we'll define the second bundle in our sequence as lying halfway between B and A along the line that connects B and A. Starting with this second bundle in our sequence, B1, we then do the same thing once again. The third bundle in our sequence will lie halfway between B1 and A on a line connecting B1 and A. Then we again start with the last bundle we defined, B2, and we define B3 as once again lying halfway in between B2 and A on the line connecting B2 and A. By now you can tell how we're going to proceed. Each time we define a new bundle, we define the next bundle as lying halfway between the previous bundle and bundle A. Thus we get closer and closer to bundle A along the line that connects B to A. We're therefore traveling from B to A by hopping along this line in smaller and smaller increments, each time skipping half as much as we did previously. You should be able to tell that we'll never actually reach bundle A even if we go an infinite number of steps, but we'll certainly converge to bundle A. We'll get closer and closer. The sequence of bundles that begins with B and then progresses with B1, B2, B3, and so forth is therefore an infinite sequence that converges to bundle A without ever touching it. Using the language of calculus, we could say that the limit of this infinite sequence is bundle A, or the infinite sequence reaches bundle A in the limit. Of course, this is not the only infinite sequence that converges to A from B. It just happens to be the one that does so along a straight line and in the kinds of steps that we've outlined here. There are in fact an infinite number of sequences we could specify that go from B to A and converge to A. All we're doing here is demonstrating the basic intuition for what we mean when we say an infinite sequence converges to a bundle. We can then appeal to this concept of an infinite sequence converging to a bundle as we define the continuity of tastes, or the property of tastes that we called the no sudden jumps property. In particular, suppose that we have two converging sequences, a B sequence that converges to bundle A, like the one we've just drawn, and a C sequence that converges to a bundle D. Suppose further that it's the case that every one of the C bundles in the C sequence is strictly preferred to the corresponding B bundle in the B sequence. So C1 is strictly preferred to B1, C2 is strictly preferred to B2, and so forth. The no sudden jumps property, or the continuity property, then says if every one of those C bundles is preferred to every one of those B bundles, then it can't be that suddenly at the very end of these sequences the preferences switch. So it can't be that at the end point of the sequences D is suddenly strictly less preferred to A, even though all the C's were strictly preferred to all the B's along the way.